Hello everyone, I'm Aditi Vyas, and the project that I'm going to be presenting today is flight delay prediction using machine learning algorithms. So the contents that we'll be covering today are introduction, aim, dataset, methodology, results, and the conclusion. So let's start off with the introduction. So this problem, which is the delay in flight, is a common problem in the aviation sector. And few of the factors which might cause it are weather change, mechanical problem, air traffic, etc. So the aim of the project is to find out which of the algorithms that I've chosen gives a better prediction in the flight delay using the data set which I've got from Kaggle. So the data set that I've chosen is a clean flight delay data set that I've taken from Kaggle as previously mentioned. So this data set consists of 50,000 entries with 20 different features like origin city, destination city, flight delay, flight number, scheduled arrival time, scheduled departure time, and departure delayed minutes, etc. This is a screenshot that I've taken as an example to show the features that are given in the dataset. So start then next is the methodology. So there are three different regression models that I'm taking for this project. One is linear regression, the random forest, and gradient boosting. So the structure of the code that I have done is as follows. First is that I'm loading the data set, then I'm pre-processing the data, then defining the target variable, splitting up the data to training and the testing data. Then I'm training the model, which is the models I have previously mentioned, linear regression, gradient boosting, and random forest. Then I'm predicting and classifying the output by actually converting the actual delay time to the binary classes for the evaluation. Then I'm evaluating those models and printing out the output. And the output are MSC, RMSC, and accuracy. So the additional thing I have done to actually check if that model is actually better or not is by using the feature importance. So the results that I've got from the linear regression, as we can see for MSE, it's 147, RMSE is 12.12, and the accuracy I'm getting it as 88%. This is the visual, the feature importance I'm getting, where it shows that, so I've taken like four weather conditions, clear, rainy, snowy, and stormy. So in the linear regression, it's actually showing that the clear is of more importance as it's giving a positive coefficient value as compared to the rainy, snowy, and stormy. Like rainy and stormy are giving negative. So whereas if we see for the next one, the random forest, accuracy is 97.42, and comparatively it's giving a good feature importance, where if we see the snowy clear is of good importance, followed by the rainy and stormy as well. Whereas for gradient boosting, the accuracy is 99.56, like bit lower than the random forest. But if we check out the feature importance, the snowy, it's only snowy which is giving like good feature importance than the rainy, clear, and the stormy. Like there's a big difference over there. So as we come back to the conclusion, so as per the results I have shown, random forest is actually giving a better accuracy than the others, which was 97, while the other were 88 and 91. So on comparing the graph, which is like the feature importance, the linear regression is giving a positive, the clear weather is giving a positive importance as compared to the others, which are two of them are giving a negative one and the other is positive but very low. And then there is random forest where the snowy and clear are giving a higher importance, followed by the rainy and stormy, like there's not much difference, which is actually good. And the third one, the gradient boosting, where the snowy is giving a higher importance, followed by rainy, clear, and stormy weather, which like there is a big gap. So as we can see, if like the higher, if all the four has like good importance, like it's nearby, not much gap, which means that it's giving a really good prediction. Like it's giving a perfect prediction nearer to that. So based on the outputs, we can say that the random forest is giving a better result. We can check it out from the accuracy and also from the graph. Thank you. This is the presentation. And now we'll be moving on to the code. So this is the code over here. So first we are importing the libraries for the linear regression, gradient boosting, and random forest. Then we are loading the data set, the one which I've got from Kaggle. I just described the data set over here to just show that, okay, how many entries are there for each one of them, which are like 50,000 entries. Then we are pre-processing the data, which is by first we create the binary target variable and then we drop the non-feature column. So over here, we are using the arrival delay minutes. Then over here, we then handle the categorical variable and the missing values. So in the first line, we are handling the missing values. And in the second line, we are actually converting the categorical variable to a dummy variable, which is like over here to the features. Then we are defining the target variable, which is the arrival delay minutes columns. And then we are splitting the data into training and the testing data set. So these four steps are actually common for all the three algorithms. Then we start on with the first algorithm, which is the linear regression. Over here, we are training the linear regression model. Sign over here, and then we are predicting and classifying the output by actually converting the actual delay time to the binary classes for evaluation. Next step, we are evaluating the model and printing the output as I had shown in the PPT. So this is the feature importance that I'm doing it over here. And this is the graph I have got. I had explained it beforehand in the PPT where this is the clear is giving a way more perfect, like high importance as compared to the others. Rainy and stormy are giving a -1. Then I'm training the random forest and I'm predicting and classifying the output over here. Then I'm evaluating the model and printing the output over here, which is giving an accuracy of 97.42, which is good. Then next is the feature importance using the weather conditions, which are like clear, rainy, snowy, and stormy. Over here, it's giving a really good feature importance, where snowy and clear are giving a high importance, as well as rainy and stormy. Then I'm training the gradient boosting model and predicting and classifying the output. Then I'm evaluating and printing the output over here. Accuracy is 91.56, which is also good, but a bit lesser than the previous one, which is the random forest. This is the the feature importance I'm getting. We can see that the snowy is actually giving a higher importance, but the difference between the rainy and the stormy are a lot, as well as for the clear and stormy. So as we compare all the three, the gradient boosting, random forest, and linear regression. So over here, the random forest is giving a better accuracy as well as the feature importance. This is my project. Thank you so much.